Thanks for the intro, and thank you for all coming to our offices. I'm Anisha, and I'm a React Native developer advocate here at Amazon. And I ordered all the pizza today, so you must laugh and you must tweet about how awesome this talk was. No, I'm joking. It's probably not going to be as funny as Michael's. Your talk was really good. So please laugh. And if you don't, just think about the pizza. Okay, so my own journey with React began in 2017, and actually the first 4 years was spent as a developer at the digital agency side of IBM. Um, so those of you here probably work at agencies, you know I probably worked on a lot of projects, and the stack was usually the same. So for most of the React Native projects, I was using Mobix and Redux as my state management system. But when I joined Amazon, my role obviously changed from front-end developer to developer advocate. And my role changed from building a lot of production level apps to more sample code. So up until now, I've been able to get away with just using context for state management. But recently, actually, I've been helping Mo back there. Everyone gives you a mention in their talk, Mo. You're really popular. With his initiative of bringing React to the big screen. And if you're interested in that, you can check out reactnative.tv.dev, where myself and Gio back there. Oh, rntv.dev. rntv.dev. But I think if you put React Native, .com, sorry, my bad. No, that one. And as part of that, yeah, obviously we've been trying to build more demo apps. And one of the demo apps I wanted to create was a state management library for a React Native Fire TV demo app. I know it's a mouthful. Because as you can imagine, on TV, like the Fire Sticks are not as powerful as your iPhone may be. So we have to optimize for performance wherever we can. So 3D might not work on our Fire Sticks as smoothly. And so my aim is to make sure that our app is as performant as it can be. And while I was doing my research, I quickly realized that there are a lot of options from back in the day. Everyone is very, very opinionated, and I really didn't know where to start. And so, like all developers, I started procrastinating as well. And while procrastinating, I came across this image in a tweet by Lee Robinson. And as you can see, after I doodled on it a little bit, um, after Redux and Mobix, there was a period where there wasn't really any major state management libraries that emerged in the React ecosystem. And it wasn't really until the introduction of hooks that we saw this resurgence in innovation with libraries like Zesta and Recoil gaining popularity in 2020. And in my opinion, it was the introduction of hooks that was that significant milestone that opened up new possibilities and unlocked new patterns that inspired developers to think about how to approach state management. So then about 3 weeks ago, while in the bathroom, because that's where we all do our best thinking, I realized something else. And that is that the introduction of hooks didn't just change the options that were available in state management, it also created a divide in the way developers learned and approached state management. And this sparked my curiosity, and I procrastinated some more. And I put all my findings in a love letter, like any normal person does. And it looks like the community thought it was somewhat interesting. So if you want to check it out, you can read it here. Otherwise, I'm just going to share what I learned while I was procrastinating. And instead of reciting to you my love letter, I'm just going to do it in a tech talk instead. So first thing we're going to talk about is how were the different learning journeys different and how did they shape each generation's perspective on state management? How can we bridge the gap between them? The options for state management in 2024, my insights, lessons, and hopefully some guidelines that can help you make a better decision. And then the impact of like the new architecture and React 19's new features on state management. So let's jump in. With the release of hooks in 2019, the way we all learned React changed, and hence React Native changed. And prior to hooks, functional components were largely used for the simple stateless rendering, while class components handled the more complex logic. However, when hooks introduced themselves, functional components gained the ability to manage state and side effects. And this altered the way we built applications and state management was handled. And so at the time, the hooks documentation assumed that the reader was familiar with class components. So those learning React post 2018 likely didn't really prioritize how learning class components, and this kind of left little incentive for them to learn that old way. And as a result, the learning journeys created this generational divide into what I like to call the two generations of React. So first we have the class component generation, and second we have the new gen of React devs. And each generation has some characteristics. So the class component gen learned React with class components like skinny jeans, use self-deprecating humor, and shows off their Harry Potter knowledge. And the new generation of React devs learned React with functional components, where mom and dad jeans have an absurd meme-based sense of humor and show off their Snapchat streaks and TikTok dances. So raise of hands, who falls into category class components? Okay, and who falls into new gen of React devs? Oh wow, okay, interesting. So you don't have to wear skinny jeans to fall into this category. Just the first thing. Okay, so let me explain this little joke. So this is sort of what inspired my article title. And it just so happens that the year Hooks was released is also likely the time that I feel like Gen Z was starting their jobs. So I just drew the conclusion that most of Gen Z likely learned React from a Hooks first approach, but that's obviously not all of Gen Z, and it's not everybody in this room clearly. So let me explain the real differences of what learning React pre and post class components was. And if someone can explain what mom jeans are, that would be great. Um, because funny enough, I actually do fall in the first category, like both generationally and as a class component learner of React. So first up, we have the new gen of React devs didn't learn the lifecycle methods. So for the class component generation, managing state meant you were forced to understand like the nuances of lifecycle methods. And these methods provided clear entry points for initializing, updating, and cleaning up state that the release of hooks abstracted away. And so this is what the code used to look like. And as you can see, there was clear entry points for managing state. So you had the mounting phase where you had the component did mount method. You had the updating phase where you had a method called should component update and component did update. And you had the unmounting phase where you had component will unmount. And as you can see, you were really forced to think logically through each phase of the lifecycle and implement your logic accordingly. So, for example, I knew like cleanup has to be handled during unmounting. Whereas now developers who've never worked with class components might not think about the component lifecycle in this way, and you might overlook some of that logic when writing code. So if you're ever wondering like where should I put my logic, like this is how things used to look like. Next, and is that the new generation love using hooks. So as I mentioned, like class components had specific lifestyle methods like should component update. And that allowed for that manual control over re-rendering, which encouraged developers to think about performance optimization. Whereas now you have the hooks that use callback and use memo. So these optimization techniques are not as explicit or intuitive, making it harder to identify when to use these hooks. And let's again look at an example, sorry. Let's look at an example. So this is, again, like what a class component looked like, right? So you had the should component update, which compared next prop, so next props.value, and the next state, so next state.count, and the current props and state to determine if the re-render is necessary. So in this case, it's the product ID. In the equivalent functional component, however, the use memo hook memoizes the result of an expensive computation, in this case, compute requirements. And then based on the product dependency, this memoized value is recomputed only if the value changes. And then you have to use the use callback hook to memorize the callback function handle submit based on the product ID dependency, which indirectly helps determine if a re-render is necessary. So as you can see, it's really not as intuitive as it used to be. You could just say, hey, re-render if my product ID changes. Whereas now you do two functions, you use two hooks that sometimes do something similar, but not exactly. So yes, the logic used to be simpler, and you were forced to think about like when to make those performance optimizations. And then I think, and this might be a bit opinionated, but I think testing became a bit easier. So the step-by-step nature of class components encouraged testing practices, and you had to address each component's lifecycle method separately. Um, Whereas now, it's sorry, class components had more explicit setup for testing as well. Like you had to mock the lifecycle methods, you had to set up the mocking of those lifecycle methods. And now, like when you're testing functional components, it's almost like a no-brainer. You're like, okay, this is actually much easier. I might as well just do it. Whereas for the new generation, it might sometimes be an afterthought. So again, let's look at an example. Uh, so this is what the enzyme code used to look like. So enzyme was the way most, I guess, class component developers tested. And in the enzyme example, you can see that you check wrapper.state. So you're checking that the actual component's implementation. Whereas in React Native testing library example, you're checking the rendered output and the actual user interactions. Like you're checking what happens after a user clicks. So you don't actually care about the implementation details. You don't care about what state used to look like or what it might look like at that point in the component lifecycle. And so you're not explicitly testing state, you're testing, or the various component lifecycle methods, you're testing like the user interaction. And yes, this is more obviously intuitive, like that is what you should be testing, but like you're not thinking about how state looked like throughout the process. And actually, there's a great blog by ColdStack that goes into this in more detail, and they do talk about the benefits of testing functional components. But I feel like that you don't really think about the whole life cycle when you test anymore, and that makes it a bit easier to test. And I don't know if that's a good thing or a bad thing, but the final one is that the new generation tend to jump to state management libraries. So prior to hooks, integrating Redux into React applications was a pain. And I mean, how many people here have ever integrated old Redux? Hands up. Okay. Old Redux, not RTK. Okay, cool. So you know what I'm talking about. It is a pain. Like, it's not as easy as it is right now with RTK. And it required a really good understanding of Flux and a lot of boilerplate code. So even though with hooks, the process of integrating RTK is easier, I feel like the scars of like having to integrate Redux in the past remind like the class component generation of the complexities that make the class component gen less likely to reach for that state management library. But I don't. But I think this did cause a pattern also in the class component generation, where they probably still reach for Redux due to familiarity, whereas the new generation devs are likely more comfortable with the newer, lighter libraries, which I'll talk about. I'm gonna forget this code example because like you can just see the Redux changed. Anyway, at this point you're probably like, cool story, bro. Why does this matter? Why am I listening to Skull speak? How is it specific to React Native? And really, if you're going to take anything away other than the pizza, like this slide is what I really care about. So it's clear that there were different learning journeys, as I showed you, and each of those learning journeys shaped how the generations approach React and hence React Native, which led to this pattern of common issues. What I feel like I've seen when handling state. So now that we understand those issues and why they occur, like I think it's important that we look at them to help bridge the gap. So for the class component generation, this is things that you can look out for and advise on. And for the new generation, it's things to be mindful of, or maybe an explanation for why the class component gen is so harsh in their PR reviews. Again, how is this relevant in React Native? Why are you as React Native devs here? So performance optimization. And I think this is the main reason like I was interested in it as well. So when we're building React Native apps, we want to manage our performance as much as we can and the overhead of the React Native JS bridge. And we do this by understanding techniques that help us avoid unnecessary re-renders, minimizing state updates, and ultimately reducing our app bundle size. And most of the time, we're not thinking about the first two things, like how do we make sure we're not re-rendering unnecessarily. And I think like these generational differences and how to mitigate them hopefully will help with performance optimization. So the first one is for those who did, for the difference where we didn't learn the life cycle methods. My advice is don't store unneeded state. So storing unneeded state can lead to unnecessary complexity, which means more places for bugs to hide and performance up overhead. And this can be mitigated by like don't store a state that can be calculated from other values or props. So instead of, for example, storing full name, calculate it from in the render method from first name and last name. Um, Second is enforcing immutability. So don't transform state data in state. Transform that data while when rendering instead, and keep your state as the single source of truth. Um, and finally, watch out for duplicated or deeply nested states. So, for example, if you had user posts comments as a nested object, use IDs to store user posts and comments separately in slices of state. Next, for using hooks, try and work on our, let's all work on our understanding of hooks. So firstly, separate concern, like don't put all your logic in a single use effect. Separate related logic into custom hooks. At the same time, multiple use effect calls with many dependencies can lead to spaghetti code and performance issues, so don't do that. Watch out for missing dependencies in use effects, as this can also lead to unexpected behavior in your application, like infinite loops. Make use of the cleanup function returned by use effects to avoid memory leaks and properly handle component unmounts. Don't overuse hooks like use memo and use callback, as this can have the opposite effect of what you intended. And avoid direct state mutations and setting state directly from props. And actually, there's a really great talk by David Khurshid about how to use effect effectively. So if you haven't already seen it, I really, really recommend it. It was at React Advanced London a couple of years ago. And then for testing became easier. So it can be even easier if we keep our components concise. So keep components focused on a single responsibility. Refactor complex logic into custom hooks. Make sure your component isn't too large. Follow principles like unidirectional data flow, atomic design, decouple them. Favor composability over inheritance. So actually, the legacy React docs had a really good page on this, and I think they've taken it out. I'm not sure, but I pulled this link from the legacy docs because I used to read it all the time. Really sad, I know, but it's really great, like to explain like why maybe if you came from a Java background, like, and you were used to class components, like why is composability over inheritance, like why do we think that way? And pass dependencies into a function or component from the outside. And then for state management libraries, and this was actually the real reason I did this talk, so that's why I kind of jumped to it quicker, but understand your options, right? So first of all, don't stick everything into one context, as this is going to slow down your app. Break it down into smaller state, like more manageable context, for something that's more specific for your application. And then understand when to use the state management library. So not every app needs a state management library. Like evaluate a specific need. For example, that could be complex data flows, large amounts of shared data, or just you need middleware. But find a need before you decide to implement the library. And then finally, be intentional when with your state management options and tooling. And that's basically what I wanted to do. I wanted to be intentional. I didn't want to just pick any option, back it in my demo app and be like, here guys, this is what I think, like you have to use it because I'm Amazon. No, I wanted to be intentional. So this is basically what I learned. On the client side right now, we have about 5 options: Recoil, MobX, Redux, Jotai, and Zastand. And for async management, we have Tanstack and Apollo Client. And here's from the State of React Native survey, which is also where I took my inspiration for the talk title. This is from 2023, the survey of the usage. And so that's where I pulled these, the options that there are. And I think 2 things to note, like from the survey that I found slightly confusing, was the async options are not mutually exclusive from the client-side ones. So you can use Zustand and TanStack together, and it actually works really well. And Redux is to RTK now what MobX is to MST, sort of. So hopefully we do see a rise in like the usage of MST in the following years. And then next, I classified those state management libraries based on their core architecture and how they handle state updates. As I found that this directly impacts, like, first of all, their usage, second, their scalability, and then the most important thing, their performance. And so this is what I came up with. So don't take this as like this exists out in the world. Like, this is literally what I classified it as. So hopefully it helps. So the four categories are centralized, whether it's mutable or not. There's the state model, and which way does the data flow. So for centralized versus decentralized, this indicates whether there's a single global store or whether there's component level or independent stores. And then for mutable, does the library enforce immutability or not? And then for the state management model, we have flux-based libraries like RTK and Zastand, where there's, for the observable ones, we have MobX and Valtio. And then you have another one where it's each piece of state is broken up into tiny pieces of, like, data code atoms. And lastly, there's state machines. And then the data flow. And the reason I did this was I found it useful to see which libraries have similar mental models. So if you're used to using RTK, then the mental model of Zastand is going to like feel familiar. So I feel like if you're coming from one generation and you're used to, say, RTK or Redux or MobX, then the equivalent like mental models of the other libraries will feel familiar. And so ultimately, the reason I did all of this and the reason I did this talk was choosing the right state management library or approach. So first, some generic advice. So only reach for a library if you have a clear use case. Like, don't just consider project size or complexity. Think about your performance requirements. And this is where I want you to take that table into consideration. So for example, centralized libraries are easier initially, but as the project scales, having all your state in one centralized library might make it harder to maintain down the line. So I think that's where like that table will help you make those decisions and help me make the decisions. Like, fine, initially, like maybe something is easier to use, but when we're building React Native apps, the most important thing is performance. So maybe the complexity of the library isn't as high, but is it as performant? Next, for React Native as well, like things like bundle size. Is it a large library? Is it a small library? And dev tools. I mean, we all know that testing on mobile isn't as easy as web. So things like dev tools are more important, like to React Native developers. And finally, and I think this is like how I ended up classifying the usage of each of those libraries. And some of this comes from this really awesome website called React Community Tools Practices Cheat Sheet. It was actually created by the main maintainer of RTK, and actually met him in Paris last week, which was really cool. But he put together this website, which I found really, really useful. And some of these are from there, some of these are my own. So if you want to know which ones are by like a really famous person, like go on the website. If you want my opinion, don't read through the notes. So RTK I found was useful for large complex apps that had a significant amount of state that needed to be accessed and modified in like multiple parts of the app. Whereas Jotai was really good for component-centric apps. So if you have an app with 20,000 components, which apparently Slack has, Jotai would be a good use case. And then there's Valtio, which is well suited for data-centric applications. So where the focus is on manipulating and managing complex data structures. And this is because Valtio actually leverages the proxy API, which allows you to directly mutate state. Then you have Recoil, which is really useful for derived data. Zastand is simple, intuitive API, which is based on hooks. So it's really useful if you want like a lightweight solution that feels natural, like to React. Mobix is useful if you have complex state that needs to be derived and reacted to in real time. And finally, there's another one which is actually on the, well, it is on the list, sorry, is legend state. And Mo told me about this again, and he was here last meetup. What's his name again? Oh, sorry. Jay, yeah, Jay, yeah, he wrote this library, and like it's great for performance. Like I saw on his on the library page, and like you can see compared to like all the other options, like it is really performant. And then this little analogy from the Jotai docs says Jotai is like recoil, Zista is like Redux. So there's 7 options, but like actually, like if you're using one, it might be very similar to the other. Um, finally, these were like my learnings, and that is Jotai, Zastan, Valtu, and Recoil are all like the lightweight options. Zastan worked really great with Tanstack. Jotai has a really simple syntax that solves a lot of the issues, like with context re-rendering. Um, RTK still, I feel like comparatively has a lot of boilerplate, but if you aren't familiar with Redux, it still might have a learning curve as well, but it's still a great option for large apps. RTK, Zastan, Jota, and Valto are all compatible with Redux Dev Tools. So if you're used to Redux Dev Tool, these are great options. Valto's documentation was a bit confusing for me. And another great article that has like a lot of their own opinions is the one on the bottom of the screen. And then that brings us to today. And the only factor left to consider is like what's happening in 2024. So firstly, the new architecture supports concurrent rendering and features that were shipped in React 18 plus. So if you're using features like suspense and for data fetching or transitions and all the other new cool stuff that's coming out of React, then Jotai, Voucher, and Rico all are designed actually with concurrent rendering in mind. So they all actually already leverage suspense. So they're actually already in a great position to take on those performance improvements that have come from the new architecture. So if you're thinking like future-proofing your app, then those 3 are really great options. With the new concurrent re-rendering features, like following best practices and state updates is even more important. Why? Because we don't want to have inconsistencies and stale state. And libraries that enforce immutable state updates and provide a clear and predictable way to manage state will be more beneficial in the concurrent rendering environment. So maybe that's another thing to think about, like why should I go for an immutable state library versus a mutable one? And last but not least, the introduction of React 19 and the React compiler does mark a significant shift in how all of us are going to be developing both React and React Native applications, because we've got automatic memoization, we've got the need for manual use of like use callback and use memo is going to probably go away completely. I don't know. I mean, they hopefully say you won't need to use it manually, and so who knows? Like at the end of next year, we might end up with 3 generations of React devs, and then I'll have to make a slide on like what Gen Alpha likes, which I have no idea. So yeah, let's hope we don't end up with 3 generations. Sorry, I whirlwinded through the last part because I didn't want to keep you here late. But if there's 3 things I want you to take away, be kind to the new generation of React devs. It's not their fault; they didn't learn class components. Um, be intentional with your state management choices. Don't just pick what you know. And finally, yeah, consider the past, present, and future when making your choices. Thank you.